Hello, this week we're going to be talking about why social researchers use statistics. So first, what is a social scientist? Well, this is a scientist or a researcher that's interested in the study of humans and individuals in relation to society. They usually come from the fields of sociology, psychology, anthropology, economics, political science, and history. So why might they be interested in using statistics? Because, like us, they're interested in predicting and explaining human behavior. So they want to take educated guesses about what is going to happen in society. Some examples of some things they might be interested in guessing about is the stock market, gambling, maybe a political candidate, test taking, or a blind date. Statistics allow them to make educated guesses in a precise and structured way. And ultimately, statistics allow researchers to draw conclusions about data. So what is data? What are data? Data can be quantitative or qualitative. Quantitative data are numbers. So strictly numbers. It can be gathered from tests, surveys, spreadsheets. Any data that is a number is quantitative. Qualitative data are usually words. Like they could be a transcript from an interview or a focus group. So if you had an interview with someone and you recorded it and then the transcription of that interview, the typed out words, that would be qualitative data. Qualitative data can also be physical documents. It can also be pictures. You cannot produce statistics with qualitative data. Statistics can only be used with quantitative data. So numerical data is the focus of this class. Social scientists typically examine variables versus constants. So a variable is something that changes. It differs from one person to the other. So some examples are age, income level, what kind of education this person has, as opposed to constants. Like, for example, mothers are always biologically female. So social scientists are interested in variables versus constants. Social scientists want to test ideas empirically. So what does it mean to be empirical? That means that you're basing something on experience or observation rather than theoretically speaking. And a hypothesis is an educated guess that social scientists make about the true nature of the world. And usually hypotheses are about cause and effect. So because blank happened, this happened. So that's what they're interested in, usually cause and effect type relationships. And that leads to what are the differences between variables? Well, there can be independent variables and there could be dependent variables, shortened as IVs and DVs. An IV is the cause and the DV is an effect. So, for example, you might be interested in, does watching violent TV cause aggressive behavior? So the IV in that situation would be the violent television, and then the aggressive behavior in that situation would be the dependent variable. Another example, does washing clothes cause clean clothes? So you can think of really simple examples to kind of test yourself. A unit of observation, because social scientists are interested in society, they don't want to focus on just individuals all the time. Instead, they want to focus on aggregates of people or aggregates of variables. So the unit of observation is usually larger than one person. It can be one person, but generally, social scientists are interested in solving a particular problem about society or something like that. So they're interested in more than just one person. There's different ways to research, as spoken about before. So there's quantitative methods and there's qualitative methods. So some quantitative methods where you could gather numerical data. You could gather it through surveys or questionnaires, maybe polls. You could run some statistical analysis, maybe an experiment. Some qualitative ways are interviews, focus groups. You might visit an archive and look up some data, look up some old documents. You could do an observation. You might do a content analysis, which is You could gather some data from online that already exists, that's a Word or a document, and then you could do a meta-analysis, which is essentially the comparing of different journal articles to be able to analyze in a comprehensive manner. So we're going to go over several of these in the next few slides. So the experiment is what social science researchers use often. And so how this works is a researcher controls an experimental situation in order to test a hypothesis. So the researcher manipulates the independent variable. So for an example, they would expose some participants to an experimental group and then some to a control group. The experimental group experiences the IV and the control group does not experience the IV. And how they decide who gets to be part of which group is through random assignment. So an example of experiment, the washing machine increases the cleanliness of clothes. And this is something that we think happens, but we want to prove that it happens. So you might have a pile of clothes and you randomly assign to different levels of the independent variable. So the experimental group, those clothes go in the washing machine, and for the control group, those clothes do not go in the washing machine. And then you can measure the dependent variable, which is the cleanliness of them, to see if there are difference between the groups. So was there a difference between the clothes that went in the washing machine, and was there a difference between the clothes that didn't go in the washing machine in terms of their cleanliness level? Another example is frustration increases aggression. So participants randomly are assigned to different levels of the independent variable. There might be a group that's frustrated and there might be a group that's not frustrated. So then you would measure the dependent variable of aggression to see if one acts more aggressively than the other. This is a funny Instagram meme that I saw recently, and basically the experiment is can be labeled down to trick or treatment. So the trick would be the control group, and then the treatment would be the experimental group. So it's just kind of funny. I thought I'd share it with you. Okay, so another way that social scientists researchers gather data is through a survey. A survey is also referred to as a questionnaire, but you can also have a shortened version, which is just a poll. The survey doesn't manipulate variables like an experiment. So for example, we manipulated back here the clothes washing. So we put one in one group, one in another group. It doesn't do that with the survey. We're not interested in manipulating. We are just interested in essentially taking the temperature of the people that we have sent the survey out to. So we're just measuring relationships between the different variables. Yeah, so we're not offering control or random assignment like the experiments. So some other methods is content analysis. This is maybe looking at books, newspapers, music, political speeches, participant observation. Like you might be interested in doing a study on heavy metal, and then you would go to the concert and observe. And then also secondary analysis or analysis of archival data. So this is data that already exists, that's been collected by a particular group and being held, and you can go review it. But all of these that are on this slide are generally qualitative methods. So why do we want to test our hypothesis? So why are we interested in studying these problems? So social research oftentimes seems like we're studying the obvious, but things aren't always as they seem. So an example of something obvious might be that those with higher levels of insecurity tend to have less satisfying relationships. So in this particular example, higher levels of insecurity, so the level of insecurity is the independent variable, and then the level of satisfaction with the relationships is the dependent variable. So this is something that we think is pretty obvious, but things aren't obvious until they're tested empirically, and then that's when things become well known, and then they seem like they're obvious, but maybe they weren't obvious at one time before. And in addition, not everything is as it seems. So we make assumptions about the world, but social reality is actually really complicated. Humans are different. We all carry different baggage with ourselves. And so not everything is as it seems. So example, most mass murderers are not insane or impulsive, but are instead methodical and selective. So you might assume that they're insane, but they're not so much. So we need methods that rigorously challenge our assumptions. So there's 5 different stages of social science research. First, you want to develop a hypothesis. So what are you interested in studying? Next, you want to decide your method, which we'll look at some different methods in a second. This also was a slide about methods. Where was it? It was a few slides back. It was where it was right here. These are some methods that you can choose from. And then once we decide our method, we want to collect the data. Then we want to analyze the data. And then we want to interpret our results and communicate them to an audience. So the majority of this class is going to be focusing on step 4, which is analyzing data. So we're not going to go out and get any data on our own, but we're going to analyze data that already exists, so that way we can see whether there are statistical relationships. But let's check out this YouTube video on some methods in social science research.
Research methods are really just techniques for helping you get to the truth. If you're looking for a set of steps that you need to take to help you investigate something, that's what research methods are. They're about what's the best way to do that.
It's basically the way in which you answer a question. So it's the way you approach it. And there's different ways to answer questions. So depending on what you want to study, there are different ways you can study it. And that sort of captures research methods more broadly.
Quantitative methods you use when you have research material in a form that can be counted.
Quantitative methods are more mathematical, so they're often to do with like big groups of people.
Generally speaking, we're talking about statistics, but really it's a way to simplify all that information and put it into, distill it down so that we can make sense of it.
Qualitative side of social science is much more about what does it mean to do this. It's about interpretation, if you like. It's about making sense of people's understandings.
It can be diaries, websites, interviews, documents, all manner of things.
We're at the start of a new age, I think, in social science, a very exciting new age of bringing these two methods together and working between them. But also we're in a new age of incredible mushrooming of the availability of a much wider range of data.
Social science research is important because it's answering questions that affect us in our everyday lives.
I think if you look at many of the big challenges facing society, they are fundamentally social or have a very strong social dimension to them.
Being able to understand the consequences of our actions in a world in which the interconnectedness of all the different bits of society make that quite hard to do, is very much why we need social science research.
It follows logically that if we're going to know the best way to address those problems as a society, we need to understand them, what causes them, what's the best way of changing things.
Okay, so this class is a statistics class, as you know, so that's going to be the focus. First thing that you should know about statistics and what we've already talked about a little bit in terms of variables. Remember, a variable is something that can change versus a constant is something that tends to not change. Social scientists are interested in variables. But there's 4 different categories of variables, or 4 different types of variables. There's nominal, ordinal, interval, and ratio. And we're going to spend the next few slides going over all of these. This is a table that describes the differences between them, and they give some examples. So let's go through this. Nominal, these are categories, but they're unordered. And there's a number attached to the category for coding purposes only. The number doesn't mean anything, but it's just there so we can use it in a statistical manner. So where do you live would be a question that you might ask someone. And then the answer would be suburb, city, town, or county. So that's a nominal type of variable. An ordinal one, these are categories, but there's an order of importance. So like nominal, there wasn't any sort of order. Suburbs aren't better than cities. Towns aren't better than suburbs. Counties aren't better than towns. In ordinal, there is some order to the category. So what is your highest level of education? Less than high school diploma, GED, some college graduate. Or another example might be, how satisfied are you with our services? Very unsatisfied, neutral, satisfied, and very satisfied. And then an interval type variable is, it can be similar to ordinal, but the space between them is consistent. So for example, on this ordinal, the second example right here, when we asked how satisfied are you with your services? Let's say we had put this as 1, 2, 3, 4, 5. Instead of naming it very unsatisfied, neutral, satisfied, and very satisfied, if we had put 1, 2, 3, 4, 5 instead, that would have become an interval variable. And the reason is because there's a clear difference between a 1 and a 2 and a 3 and a 4 and a 5. There's not an extremely clear difference between very unsatisfied and unsatisfied. I mean, what does that mean? What's in between those two? That can be decided by the person, and we're not exactly sure. They don't have all equal space between them. So it can be similar to ordinal, interval can be, but we can't say with certainty because everyone thinks that spaces between ordinal are not the exact same. And then a ratio is similar to interval, but there's a 0 in there as well. So this makes a difference with the statistical analysis that you can calculate. Yes, all right, so let's go on. Okay, so yes, it's important to know which type of variable you have because only particular statistical analyses can be run with particular variables. So as you get more comfortable with statistics and with the different types of variables, you'll start to see that you need particular variables in order to run certain statistical analysis, which we will talk about all the different types of statistical analysis that you can run throughout this semester. So let's go a little bit more into detail with all these different types. So nominal, that would be categories are unordered with number attached to it for coding purposes only. So an example is you might be measuring the attitude toward Latinos. 1, that just might stand for prejudice, and 2 might stand for tolerant. In ordinal data, or ordinal level of measurement or ordinal variable, I'm using them all interchangeably. This is a ranking individual cases based on how they have certain characteristics. So it tells us the order, but it doesn't tell us the difference or the strength or between the individual cases. So for example, like I said back here with very unsatisfied, neutral, satisfied, what's the clear difference between gold and silver and bronze? We're not exactly sure the exact differences between them, but there is an ordinal. There is an order to it. So this is some, we might be doing an attitude of college students towards Latinos. These are our students, and then this is the order of what they had ranked in terms of their level of prejudice. Interval data tells us about the ordering of categories and the value or distance between them. So it uses consistent levels of measurement. So maybe these students had taken a test that measured their level of prejudice towards Latinos, and these were particular scale scores that they got. So there's a clear difference between what is 20 versus 21, what is 94 versus what is 95. It's clear that we understand differences between those. They're all consistent. And then ratio data is the same as interval, but again, a 0 exists. So Sally, for example, scored a 0. So it was possible that that you could score a 0 on this scale. So again, it's important to know these different types of data that you have. And it's important to think ahead because, for example, if you're going to do a survey, you might want to ask in a particular way so you get particular types of data. That way you can run certain statistical analysis. So here's an example of the same question being asked with different types of nominal, ordinal, or interval. So nominal, are you currently in pain? Yes or no? How would you characterize the pain? Sharp, dull, throbbing. Ordinal, how bad is the pain right now? None, mild, moderate, severe. Compared with yesterday, is the pain less severe, about the same, or more? So as you can see, the categories here are in a particular order. Compared to here, they're just not in an order. And then interval or ratio. An interval would start at 1 through 10. A ratio variable could start at 0 through 10. So it really depends what kind of statistics you want to be able to run to be able to see. So that's why it's important that you know this so you can write your questions correctly if you were to do a survey. So there's two types of statistics, two branches of statistics. There's descriptive statistics and inferential statistics. So descriptive statistics just involves the display and summarization of data as is. It's just describing the data and not trying to make anything more of it. We tend to use this a lot on the day-to-day. And then inferential statistics involves using a sample of data to draw conclusions or make inferences about a population. So inferences could be about relationships, significance, correlation. Inferential statistics is used a lot in social science research because we want to solve societal problems. So we're social scientists. So we want to be able to solve world problems that affect lots of different people. So we're interested in inferential statistics. This class is going to be covering both. We're going to start with descriptive. Let's skip this one. Let's go to this slide. I meant to cut out the other slide. You can just ignore that one. So some examples of descriptive statistics. This is stuff that you've been hearing about since you were young. So you heard about mean, median, and mode. You heard about percentages, bar charts, pie charts. You've also done frequency distributions, and I'll remind you what that is in a minute. But these are some examples of descriptive statistics. So here's some data. Let's say that you are a teacher and you gave out an exam for 20 students, and these were all the exam scores. So they're just sitting there as is. These are the exam scores. A frequency chart to be able to describe the data would be in this way. So one student got 90 through 99, and I can confirm that right here. That's that student. There's just one. 5 students got between 80 and 89. So here's 1, 2, 3, 4, 5. Let's see. 2 got between 30 and 39. Here's 1, and here's 2. So it's just organizing the data or describing the data in a way that can make sense to people and that you can really see and analyze it to be able to see, how often it occurred. But descriptive statistics can be not just with frequency charts. Like I said, you can do any of these different types. These are all different types of examples of descriptive statistics to be able to describe the same thing, this data. So here's another way. This is the exact same data from over here. It's just described in a bar chart way. So you can see that there's not a lot of people got a 90 and a 99. Not a lot of people got through 20 through 29, which is great. There's a lot of people that were kind of in the middle right here in terms of their exam grades. So to reiterate, descriptive statistics doesn't try to make anything more of it than what it is. It just displays the data as is in a more understandable way than having the numbers just sit there in a pile. So you can describe it so it's more consumable by people and describable. So the other branch of statistics is inferential statistics. So this goes beyond descriptives. It wants to make inferences based on a sample that we want to study. So inferential statistics can help us generalize our results from a small sample to larger populations. So what is a population versus a sample? So a population is the collection of all outcomes, responses, or counts that are of interest to us. We would love to get data from a full population, but it usually isn't practical or possible. So let's say as social science researchers, let's say that we're interested in studying principal satisfaction with their school performance. Is it possible to survey every single principal in the United States? Even though all principals are probably our full population because we're interested in studying principal satisfaction with their school performance, we can't access all principals. It's just not possible. How would we even begin to do that? So we probably just have to be satisfied with surveying some of the principals. And then this sum is a sample. That's what it means. This sum is a sample of the population. So again, a sample is a subset of a population or a sum of a population. And there are different types of random sampling techniques. So you don't want to just grab certain principles that you know. You're interested in being able to generalize to an entire population. And so there are different ways that you can do that, but it needs to be random. So there's simple random sampling. And then here's an example right here. So this is a car parking lot. In a way, let's say we're interested in studying something about cars, and to choose which we can't do the study on all the cars, so we want to choose a sample of the cars. So with a simple random sampling, each car has an equal chance of being chosen. This one could be chosen, this one, this one, this one, this one, this one, I don't know. All of them, any of them have an equal chance of being in your study. A cluster sample, an example in terms of the car situation, would be you're choosing sample from each row of cars. So you choose one from here, 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 one from here. Or those are columns. Rows would be one from here, 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 and here. And then a stratified sample is that you arrange cars in rows by color. So maybe you get all the black cars to park together, red cars, white cars, silver cars, green cars, blue cars, and then you take a sample from each row. And then systematic sample would be you just count cars in every maybe fourth, for example, or whatever you wanted it to be. That would be who gets included. So 1, 2, 3, 4. This car gets included. 1, 2, 3, 4. This car gets included. 1, 2, 3, 4. This car. 1, 2, 3, 4. This car, etc. So those are all different ways to randomly grab cars and put them in your study. There are other types of sampling techniques, but they're not random and they're generally not used in academic research except for particular situations, and we'll talk about that later in the semester. But that is how you get down from your population down to a sample, so it's manageable. And that's used in inferential statistics. So here's a visual of inferential statistics. So here's our population. So this is our full parking lot of cars. And we choose a sampling method. We choose one of these methods right here, simple cluster stratified or sample. And then here we have our sample. So we've chosen the method. Here we have our smaller group of cars. And then based on this, we can make inferences or conclusions about the population based on the sample. The example from here too is maybe our population is all principals. and we decide our sampling method, and then we just have some of the principles, and that sum makes up our sample. Based off us studying that sample, that sum of principles, we can make inferences or conclusions about the population. Another inferential example, so hypothesis might be male UNT graduates are more likely than female UNTD graduates to have tried marijuana. So it's hard to reach all graduates, right? It's a little bit easier to reach all students, particularly we're a small institution. So, we have all the email addresses of all students. We could send out a survey. But generally, it's not going to be easy to reach all graduates. We can't keep in touch with them. We're not sure, where they're at or anything like that anymore. We might not have a current email address on them, a current even mailing address or phone number on them. So instead what we have to do, our entire population is UNT graduates, but because we can't access them, we have to survey a sample of the UNTD graduates. So let's say we sent out the survey, we grabbed our sample and we sent it out. We sent out the survey to our sample, and this is what we got back. So males had reported that 35 have used, 65 haven't used. Females reported 15 and 85. So we had 100 males and 100 females participate in the survey. The results, remember our hypothesis is we thought that males were going to use marijuana more than females. So that's what our survey results showed as well. It said that 35% of males used and only 15% of females used. However, can we say that the sample generalizes to all UNTD graduates? Maybe. So yes, theoretically, yes, it's supposed to, because here's our population, we chose a sampling, we have our sample, and we can make inferences. But the way to be able to verify that our hypothesis is true is ensure that there was no sampling error. So as long as we need to make sure that we follow one of these ways that we can sample. But say, for example, we chose the stratified sample, and let's see, for our example with the students, let's say we had biology graduates, business graduates, math graduates, education graduates, etc. And we had chosen a certain amount, but let's say we forgot to choose one of the majors, like maybe an environmental science major or something like that. If we didn't include them, they were part of our population, but we didn't include them in our sampling, that could lead us to say that it's not true, that our sample was wrong, we had sampling error, and so we can't make inferences about the population. So it's important that your sample is correct. And then another way to verify the hypothesis is indeed true is seeing if there's statistically significant differences between males and females. And so that's going to be a huge focus of this class, is by once we have the data, is plugging it in to a statistical analysis software and being able to see if there's statistically significant differences between them. Yes, that is the end of this lecture. And if you have any questions, please contact me. Thank you.